Hello, we are discussing about GATE 2014. GATE 2014 ECE paper held on 15th February morning session. So here this is related to the digital electronics and given as input frequency for the given counter is 1 MHz. So the clock frequency is given as 1 MHz over here. That is for Q1 flip-flop, the input frequency is given as 1 MHz. Then the output frequency observed at Q4. Q4 output is nothing but over this place. What is the frequency you are going to find over here? That is what we are going to calculate. So look at this one. We know that one, a T flip-flop or JK flip-flop works as divide by 2 counters. A T flip-flop a T flip-flop or JK flip-flop can work as divide by 2 counter if T is equal to 1. T is equal to 1 and this is going to be the input frequency Fi. At that time output frequency at Q is going to be F0 is Fi by 2, which is nothing but divide by 2 or modulo 2. Divide by 2 frequency counter frequency. The output frequency is divided by input frequency whenever for a T flip-flop T is equal to 1, and if you are applying any frequency at that time output will be half of input signal. And we know that one for the JK flip-flop is also the same thing. If J is equal to K is equal to 1, that is J is equal to 1 and K is equal to 1, at that time it is going to be similarly works as T flip-flop. By that time whatever the clock you are applying input frequency and output will be exactly half of input signal. So F0 is nothing but Fi by 2. So either JK flip-flop or T flip-flop, if the input is going to be tied at 1, logic 1, and output frequency is exactly half of input frequency, that's why they can act as divide by 2 frequency or divide by 2 counters, we can say it. So based on this principle, Q1, and here it is not given, this is connected with J is 1 and K is also 1. It is implicit, it may be by mistake. So the frequency over this point is nothing but half of input frequency, that is 0.5 MHz. 0.5 MHz is going to be getting half because J is equal to 1, K is equal to 1. Output frequency is nothing but 0.25. 0.25 is nothing but here you are going to be getting it as 0.125. 1 MHz divided into 0.5 MHz, 0.5 MHz into 1.125, 0.125, and the frequency over this point is nothing but 0.060625 is nothing but 125 and 60 62 625 0.625 MHz. So frequency at Q4 is going to be treated as 0.0625 MHz, which implies nothing but 62.5 kHz. This is the required answer. The output frequency at Q4 is 62.5 kHz, and similarly you can also calculate F at Q5 is going to be, again it is half of that one, that is nothing but 31.25 kHz. And you know at F3 0.125, the answer is nothing but correct answer is this one, 62.5 kHz. Thank you.